I'm going to treat tonight like the second lecture in a series, but it's still very informal. So if you want to add things or subtract things or challenge things or question things, you're welcome to do that. So I'm going to start by kind of going over real quickly the topics that we hit at that talk way back now in, I can't remember, August. Okay. So I want to do that quickly, and then there is that lecture on video if you want to get more on any of these things. But we started by talking about what is our aim when we're talking about sustainability. Sustainability is really a big universe. And it's on a spectrum. If you want to kind of subjectively say there's bad things that we can do and there's good things that we can do, and sustainability sits somewhere in there. And beyond sustainability, there's this whole kind of notion of abundance and production, which is really what nature does. Nature isn't sustainable. Sustainable is a very weak way to think about nature. Nature is fecund, it's productive, it's regenerative. And so if we aim at being sustainable, archers know that you don't aim at the target. You always aim above the target, and then things drag your arrow down to your target. So the art of archery is how far above do you aim in order to reach your goals. Then we talked about this whole divide between us as humans and nature. That there is this kind of traditional, philosophical, academic divide that has not always been there. But especially in the industrialized world and in modern thought, there's this kind of divide between who we are as an organism and everything else. And the real opportunity is to not think of that as a divide, but to look at us as a subset of nature. So really it's not this, it's this. And that bubble goes away. So we are a small part of a very large, complex thing. So large, so complex, that we really have no idea what we're talking about. And one of the things that I'm going to follow up on tonight is to embrace this idea of ignorance. I'll get to that later. Then we talked about sustainability really being a playground of 5 things primarily. You know, these are big categories, and you could certainly argue that this is a weak way of looking at it. But if you look at things as water and all the water-borne energies and materials, and air, and soil, and energy, and community, and by community, I'm not talking about just a human community, but also all living things coming together. Where all of those things intersect is really where we need to focus our attention. Now, it's hard to focus attention on very large, complex things, so we often focus for a moment in time on one of these things so that we can come up with a strategy. But once we do come up with a strategy to, like, reduce water or increase the amount of renewable energies that we have, or something that we do to protect soil, we should then go back and double check our thinking against some of these other things to see that we're not robbing Peter to pay Paul in the way that we think about things. Then we talked about the problem with budgets. So one of the things that when you work in sustainability, one of the things that always comes up is, yeah, but is it worth it? Well, now you're into the question of, I can't answer your question because I really don't know what you mean when you ask the question, is it worth it? Are you talking about the way I look at budgets or the way you look at budgets? Are you talking about what is accounted for in your budget, the internalities? Or are you talking about what isn't accounted for in your budget, the externalities? So the internalities of a budget are all those things that we constantly add into our budgets. Like on a building project, it might be the land costs and the labor costs and the material costs and the permitting and the fees and all those things that it's easy to put a number to. unaccounted for in almost all budgets is that stuff that we don't pay any attention to because we're not required to. So when you build something, what you built has a carbon cost, right? There's all the embedded carbon in the materials. No one counts that. When you build something, it sheds water into the larger community, almost always in a polluting way, in a damaging way. No one counts for that in the budget, but the larger community has to accept that and then deal with it. So somebody is paying. Then we talked about poor design being subsidized. Costs are moved out of budgets. There's all kinds of things that we subsidize, and we don't even know it. Transportation is subsidized. Energy is subsidized. The way we remove carbon out of the bank, out of soil, and fossilize reserves and move it into the air, that's subsidized. All kinds of things become. So these are the things that we have to identify before we can answer these questions up here. Then we talked about the way that we can begin shifting from this mindset of current business as usual and moving it toward a new way of thinking is to begin shifting from the way that the dominant way of thinking to a less dominant way of thinking. Not getting rid of these, but bringing those into balance. So rational thought should be balanced out by intuitive thought. We don't typically account for or cherish or treasure intuitive thinking in a lot of the things we do. Analysis thinking needs to shift toward synthesis thinking, pulling things together in unique new ways. Reductionist thought, in order to wrap our mind around a lot of things, we have to break it down to a very concrete, small-minded thing. But we should at least acknowledge that in order to solve the problem, we have shifted to a very small way of thinking about things. And once we come up with a solution, we should now shift back and double-check ourselves. And linear thinking should move into non-linear thinking. We should look for webbed relationships. All of these things in balance are more like the way nature works if we were to put these kind of qualities onto a system that really is quality-less. It just is nature. In terms of values, we often value expansion over conservation. We value competition over cooperation. We identify success almost always quantitatively as opposed to qualitatively. So more, that's the answer. Well, the real better is better, not necessarily more. So quantity is favored over quality sometimes. And then there are all kinds of, these are the isms, the domination over partnership, that's racism, sexism, and ageism, and all of those things that we should check ourselves against. Both the overt kinds of ways of thinking about those things, but the kind of quiet ways of those things happening as well. And then I told a story about trim tab. A trim tab is a little bitty flip on the aileron of an airplane. So pilots use it to set things so that everything is balanced out and they don't have to fight the rudder. They're also on ships. But the other thing about them is really moving a little thing a little bit shifts the whole mechanism. So that's everything we talked about. So why didn't I do it that quickly last time? So now we're going to come to today's lecture. Well, in this one I talked about the problem with budgets. Now I'm going to talk about the problem with ecosystems. Wow. You know, we're going to shift tonight, and I'm going to talk a little bit more from an ecology perspective. So disclaimer, I'm an ecologist. Among the other hats that all of us wear many of, I am an ecologist. That's what I studied. That's really what I began studying probably as a 5th grader, where I started building my collections of insects and rocks and minerals, and bird nests, and feathers from things that, anyway. So the problem with ecosystems is there aren't any. That's an odd thing to say. So let me explain that. For biologists and ecologists to study something, we do the same thing that I was just talking about over here. We reduce it to a knowable field of learning, if you will. So all of nature, to an ecologist, gets dropped down to something that is studyable. A forest, an island, an atoll, a cloud forest, a pond, whatever it is. But the trouble about reducing nature to any sub-piece of it means that we've lost really what's elegant about nature, and that is everything is connected. And so we begin thinking of organisms as individuals. We build individuals into populations. We build populations of things into communities, and then communities of things into ecosystems. And we talk about them and we study them. So the first thing that an ecologist has to do when it's studying something or measuring something is that it has to draw a boundary around something, and then you start talking about, well, everything within this boundary operates this way. But there is no boundary. Well, there actually is. We should stop thinking about, this is the same problem as with budgets, right? This is exactly what we were talking about with budgets. So if you were to ask an ecologist, well, do things at the ecosystem really work? A good ecologist should say the same things that we asked about these budgets. Well, whose ecosystem are we talking about? Are we talking about your ecosystem or my ecosystem? Are we talking about the ecosystem that accounts for just the internalities of that ecosystem? Or should we be talking about what isn't accounted for? The air that's moving across that porous border, the water that moves in and in, the immigration and the emigration of the organisms that are moving in and out of that ecosystem. So this is really now, I'm talking about this at an ecological level. So really, it's that admonition to ourselves to think locally at the same time that we're thinking globally. It's like all politics is local. Well, to some extent, that's true, and to some extent, that's not true. So we have to keep both of those. So that's that nonlinear thinking, right? It's that irrational thought that we have to pull in. It's those things that we're on that other than this. Now, in the business world and in the world of designing things, this is kind of forced into the equation. So just today, across my desk, came a report from McKinsey and Company. Anybody familiar? They are business people would be reading this. They are reports that are pulled together by an independent think tank that kind of forecast what business people should be thinking about. And they pulled one out today called A Roadmap to the Future for the Auto Industry. And so things happen to force us in the world of designing things to think in larger scales. So what they're saying to the auto company is, here we've done an analysis of all you guys out there building these things called cars, and here's what we think the future will be. And there's some interesting things in here. First of all, they think that the demand for horsepower is going to fall away in favor of the demand for data. That's an interesting. So in the future, people will select cars not for how powerful and how fast they can go in terms of miles per hour, but in terms of how powerful and how fast they can gather and provide and analyze data that the driver wants to use. That's an interesting thing to think about. The other thing that they are, and this is based on trends, the other thing that they're looking for is regulations outside of the auto industry that will drive demand on the auto industry. And some of those things are things that are already happening. In some places, there are so many cars, there are more cars than there is infrastructure for cars. So they are rationing cars on license plate numbers. Odd license plate cars can drive today, and even license plate cars can drive tomorrow. And if we catch you on the road with the wrong license plate, you're fined. And so we have already exceeded an ecologist would use this term carrying capacity, and I'm going to get to that right here. So rules and regulations and permitting can change the way we look at boundaries. Here's another example in the built world. In certain places in the United States, like Chicago, the capacity of the community to accept the runoff from the built environment has exceeded the infrastructure. So some cities, Chicago is an example. Chicago has all this surface area. When the rain falls, it hits those surfaces. And then it flows away from those surfaces and into the infrastructure that the city designed. Those are storm drains and retention ponds and those kinds of things. So it's maxed out. So what are your options when things max out? Your options are pretty much twofold. If you're going to keep the mindset of more is better, which is kind of what they've kept the mindset at, they said, okay, if you build a new surface within our city that is bigger than a certain square footage that rain cannot soak into, you now have requirements to hold on to that water so it doesn't enter into the storm drain. And here's some strategies for you to do that. Or they could decide to go back to the populace of Chicago and say, in order to get more big companies moving into our community, we have to upsize our storm drains. So a mile of storm drain is $30 million. So do you want us to tax or find funding for $30 million of one more mile of storm drains? Or would you prefer that we require new businesses moving into the community to hold on to that water through other strategies? Well, you can go either way, right? So that's called carrying capacity. So now I want to talk about carrying capacity. Ecologists use that term. So carrying capacity is the inherent ability of a place to do something. So it's the amount of energy, food, habitat, and air, water, soil, energy, and community relationships that a place allows. So let's say there's an axis for quantity and an axis for time. And within our environment, there is something that wants to limit the number of bobcats that can live in the environment. Well, what limits the number of bobcats that live in an environment? Well, it's probably prey, the things that they eat. So the environment only has a certain prey level. So the bobcat population over time can grow until it meets that limit. But what happens when it meets that limit? Nothing. It's fine. It's met the limit. But these bobcats don't know they've reached that limit. They're not going, wait a minute. They're not in collective bargaining to get more prey or anything like that. So they exceed their limit. But that puts a stress on that bobcat population. Now there's not enough food to go around. And so after they exceed that limit, they start to come back down below that limit. But again, they don't know they're going below a limit. And the limit might be the number of prey that allow female bobcats to get enough energy to have more than one offspring. So above that line, they don't have enough energy to have more than one offspring, so their population starts going down. But now they're below the limit, so they start going up again. And so in nature, what you find is cycling around some kind of a real limit in the environment. We get We don't do that. What we do is we so let me do us in another color. So here's the way we've been behaving. So we reach a limit, like the bobcats. We exceed it. And then we address the demand some other way. We industrialize our food process so that prey is not a problem. We increase the way we deal with agriculture. So now all we have to simply do is we shift this limit up here so that we can continue to grow to a new limit. But we'll cross that one too, because we're robbing Peter to pay Paul to get to that limit. So once we get there, we set a new limit and a new limit and a new limit until we get to a point where it's diminishing returns. And on certain things that we're doing, there are diminishing returns. So whatever sets this limit is the most limiting thing that happens to be in any environment. In some environments, that might be water. There's simply not enough water to make more corn. Can't do it. It's not here. And to get it here is more expensive than the return on an investment. So water is a limiting resource in certain places. Air quality becomes a limiting resource in other areas. Available metals or minerals or micronutrients become a limiting resource in other areas. But we constantly look for what we think of as an intelligent way to answer that problem. But almost invariably, we find that the veil of that falls away. Now, there's a word that I've come to learn recently that I'm thinking about in an entirely different way, and that is the word apocalypse. Okay, pretty dramatic word, because in the modern way of looking at apocalypse, we think of it as the end of the world. But if you go back to the Greek origins of the word, what it means is an unveiling, to pull back the curtains away from, to show, to illuminate. And so I think we're living in the apocalypse. But I think that's a really beautiful thing, because I think what is happening is we are unveiling this false reasoning of limits. And interesting things happen when we began really putting a name to these false limits. So you get interesting things happening, like the Rockefellers divesting from oil. That happened recently. So why? Oil is not a good investment for their portfolio. Okay? So interesting things begin happening. And I think we are living in an age, and definitely young people are living in an age, where a lot of these veils are going to come away from what we think is reality. Now, who knows? Maybe, maybe not. But at least that's a possibility. So, now I want to talk about the marriage of efficiencies. And I want to tell you a little story. And then I'm going to talk about shifting our focus, and then we're going to get into the group activities. We look at things as being efficient or inefficient, but we are often looking narrowly at things. So I want to tell you about the Wilson Creek stream restoration effort at Bernheim. There's a stream at Bernheim. All my lifetime, and for the past 100 years, it's a stream that has run down the edge of a valley. So if this is a valley, and the stream is running down and it slopes up on either side, it used to snake through the middle of that valley. And then a farmer moved into that valley over 100 years ago and began shifting that stream to one side of the valley in order to become an efficient farmer. So to do that, they used plows and mules and dredges and handwork, and they began working with the moving water and slowly shoving it to one side of that valley. And in the process, they straightened the stream along the edge of the valley. That has happened to over 85% of the streams in Kentucky. I don't know about Indiana. Probably not so in Indiana because we have there's a different topography up here. But they did the studies, they looked at the maps, and they quantified the miles of stream that had been channelized, and it's 85%. Huge number of streams. The reason was it made all that bottom land efficient for farming. So every efficiency has a marriage to an inefficiency. So here's what happened. That inefficiency did this. So by moving that stream to the edge of a valley to become efficient for farming, they made the stream efficient for getting rid of soil, which means it was inefficient for farming in the long run. So how does it do that? Well, when you channelize a stream, you turn a curvy path into a straight path, and a straight path has higher energy. If you play the video games, do you play the video games where you drive race cars around the racetrack? Where do you go fastest? When you're going straight. So does a molecule of water. And so the faster it goes, the higher the energy it has. The higher the energy it has, the more it moves soil out of the valley. So what we thought of as an efficiency at one point in time was good. It made that farmer more efficient. But over long periods of time, it made that land less efficient because we were moving the soil out of that area. And then I want to talk about focus shifting. Because when you're doing something, you're often focused on the thing that you're doing, the project, and the materials and the time frame of the project. And that's true for an artist project or a building project or anything that you do. And this is the last story before we get into teams. So when we focus in order to accomplish something, we should periodically defocus and pull our attention back to the bigger whole. And so it isn't the last story. The last story is about ignorance. So we should approach things from this kind of focusing in, pulling out, focusing in, pulling out. In terms of that focus shifting, I want to tell you the story of the Bernheim Visitor Center. Wood. So we built a visitor center at Bernheim, which was on track to become a LEED Platinum building. And we did that. We got LEED Platinum on our building. And in the process of building it, we decided we wanted a wood structure. But we were looking at the project and the materials, and we were saying, okay, to meet the demands of LEED, and I'm not going to get into LEED, but one of the requirements is to have a high percentage of recycled materials. So we said, well, how can we do that with our wood? Well, the answer is pretty easy. You have to find wood that's been used once before. So we put the word out into the bigger world that we wanted some wood. And we got an interesting call back from the H.J. Heinz Pickle Company up in Ohio. They said, we're getting rid of these. Has anybody heard this story, been out to Bernheim? Because I tell this story because I think it's cool. But so they said, we've got these really big vats. They're wood. They're big barrels. They're 18 feet tall and about 30 feet across. And inside of those vats, we make the brine solution to put on our pickles. And we've made the decision to get rid of them. So, do you want it? We said, yeah. So we got the wood. They got a tax write-off. Win-win, okay? So we went up to Columbus, Ohio, took apart the big barrels, stacked the wood on trucks, rolled it back to Claremont, Kentucky, where we are, and looked at it. We eventually sent it to a mill to be milled into tongue and groove lumber and laminated into columns and beams, and we were feeling really good about it. And it is a good story. We built our building mostly out of wood that we didn't have to cut down and have milled into wood. It had been used once before. But we were in a meeting, and we were talking, and we said, well, what kind of wood is it? That's an important thing to know if you're going to build a building out of it, right? Well, it turns out it was cypress. Cypress is great wood to build with. It's rot resistant, it's insect resistant, It's beautiful wood. You can bury a cypress board in the ground, come back 25 years later, unbury it, dust the dirt off, and use it. It's pretty amazing. So we were excited. But then we said, oh, where did it come from? Well, it came from the pickle vats, yes, but where did it come from before that? Well, we're biologists and ecologists. There's only one place you can get cypress wood. That's from a cypress swamp that grows in wetland areas. Well, one of the first rules in ecology is at kind of all costs, protect wetland environment. So we said, so a cypress swamp got cut down to build the pickle vats that came apart to build our building. Are we responsible for the loss of that habitat? Now that's a question that you can answer either way. You could say, yep, we're responsible, or no, we're not responsible for that. Don't be ridiculous. That was over 100 years ago. We were not even thinking of a building 100 years ago. Nobody here is connected to anybody there, completely separated from us. But that would be like thinking here at the community level and not at the ecosphere level. And so it didn't matter to LEED. LEED doesn't care. But we decided to take responsibility for the loss of the habitat. So we went to a lake at Bernheim and we planted a 5-acre cypress tupelo swamp. And over time, we planted little trees. They're as big as my thumb. But today, they're that big. And, you know, when my daughter goes back as an older person, they'll be this big. And we planted them to pay back the 5-acre. Well, we determined from the square footage that 5 acres would repay the lost habitat that built the pickle vats, that built the building. So that's a much better story, right? So we did. But that's not where it ends. We were then in another meeting and we said, wait a minute. We are essentially just building the next generation of pickle vats, right? We took that wood and we're building something. And it'll have a lifespan, like those pickle vats have a lifespan. And at some point in the future, even though it's LEED Platinum building today, it won't be the bee's knees down the road. So shouldn't we build it with the ability to come apart so that some future generation can disassemble it like those pickle vats got disassembled and turned into a visitor center? So we called our architects. Architects don't get calls from us all the time. And we said, okay, hold your drawing pens. We want the building to come apart at the end of its life. We want you to think of this building as having a time horizon, and that the materials that are in it should have a life beyond our project. So design it to come apart. So long story short, they did. And so our building has a construction plan and a deconstruction plan. So now we're thinking like nature. And that's my admonition in the last story here, except for the one on ignorance. And so to think like nature, you have to think in cycles. You have to think far beyond the horizons of what you think is your project, because it's not your project. Your project has fingers into the past, and fingers into the future, and fingers to the entire ecosphere, not the ecosystem. This doesn't exist. This is a false way of looking at a piece of this. Now, ignorance. This is the last story. There's a great book called The Virtues of Ignorance, and I highly recommend it. It's by Bill Vitek and Wes Jackson. Wes Jackson is the gentleman who runs the Land Institute out in Saline, Kansas. And it's got a great first chapter in here by Wendell Berry. But here's what they're saying. The human species, our long suit is ignorance. We are far more ignorant than we are knowledgeable. We know a lot, and that intelligence that we know comes in lots of different forms. Traditional knowledge, and intuitional knowledge, and empirical knowledge, and scientific knowledge, and all these different kinds of, but we're still know far less than we do know. And so let's go with our long suit. And when you approach things from a position of ignorance, you approach things in a much different way. You are careful because you don't know what you're doing. You save all the pieces because you may be putting them together wrong. And you might want to reassemble them in a more correct way down the road. You admit that you don't know everything, so you get in conversations with people to help figure out things in a different way. And you are approaching the way we do things in a humble way. When you approach things from a position of knowledge, you dive in because you know what you're doing, right? There's no reason to ask anybody anything. And because you know you're right, there's no reason to save the pieces. We're going to do it right the first time. And all these different ways of thinking. So the last story before we divide up into teams is let's approach what we do from a position of ignorance. And that's really kind of a freeing thing to do. To not always have to think that we know what we're doing. Let's move forward carefully and humbly. And let's keep all the pieces. And let's ask questions. Let's definitely question the assumptions, because the assumptions are almost always weakly positioned.